Okay, now we want to talk about monotonic functions in the first derivative test. Now suppose that f is continuous on an interval from a to b and differentiable between a and b. Then f prime of x is greater than 0 at each point, then f is increasing in that interval. If f prime is less than 0 at each point, then f is decreasing on that interval. So what that says is if we have intervals where all of the slopes are positive, then f is increasing. If we have an interval where all the slopes are negative, then f is decreasing in that interval. Now a function that's increasing or decreasing on an interval is said to be monotonic on that interval. Now let's take this example, and we want to look at where it's increasing and where it's decreasing. Now, if we want to know where it changes from the slope being negative to the slope being positive, we need to first look at where the slope is 0. So we take the derivative of our function. Our function was f of x equals x cubed minus 12x minus 5. So our first derivative is 3x squared minus 12, and of course the derivative of 5 is 0. So we're looking for where this first derivative is equal to 0. Okay, so I can add my 12 to both sides. 3x squared is 12. Divide both sides by 3, x squared is 4. And when we take the square root of both sides, remember we have to include plus or minus, and the square root of 4 is positive 2 or negative 2. So we can see at negative 2 and at positive 2, both of those places, our slope is 0. Now if we look to the left, you can tell that this graph is increasing, it's decreasing between the 2 points, and it's increasing to the right. Now if we pick any point over to the left of negative 2, like say negative 3, and we look at f prime of negative 3, f prime of negative 3 is 3 times negative 3 squared. Negative 3 squared is 9 times 3 is 27. 27 minus 12 is 15. And similarly, any point over in this interval will give you a positive slope. And you can tell that because you can tell that at any point here that the tangent lines have positive slopes. Now if you pick a point between negative 2 and positive 2, like say 0, and I'm just picking points at random here as long as it's in the interval, and we plug in, that's 3 times 0 squared minus 12. 3 times 0 squared is 0, so that's negative 12. And so we have a negative slope. So all of our slopes are negative here when it's decreasing. And then if we choose a point over here like positive 3 is going to be the same as negative 3. 3 squared is 9. 3 times 3, sorry, that's a minus. 3 times 9 is 27, minus 12 is 15. And so again, over here, all of these slopes will be positive. Now I just picked 3 particular points, but you could pick any point in any of those intervals. So it's monotonic on those 3 separate intervals. And this is just a slide that shows those same values I just found. Now what a function's first derivative does is it tells us about how a graph rises and falls. Now when the slope is positive, we know that it's increasing. Now when it's 0, it could be changing from increasing to decreasing, but not necessarily. Here it does not have an extreme value. It does not necessarily have to have a high or low point where f prime is 0. And it keeps increasing. But notice here where f prime is 0, it goes from increasing to decreasing. And here it goes from decreasing to increasing at this minimum. It goes from increasing to decreasing here where it's undefined. And then here, there's no local extrema. It goes from decreasing, and it's still decreasing. Okay. What our first derivative test tells us is that if c is a critical point of a continuous function, f is differentiable at every point in some interval containing c except possibly at c itself, moving across c from left to right. If f prime changes from negative to positive at c, then f has a local minimum at c. If f prime changes from positive to negative at c, then f has a local maximum at c. If f prime does not change sign, then f has no local extrema at c. Okay, so just like this example we had, if it doesn't change, it's either positive and still positive, then there's no extrema. If it's positive and changes to negative, then it has a maximum. If the slopes are negative and change to positive, it has a minimum. Okay. Now let's take this example. And here we have x squared minus 3 times e of x. And let's look at where it's increasing and decreasing. So let's find the first derivative. That's a product rule, so we take the first function times the derivative of the second plus the second times the derivative of the first. So that will be x squared minus 3, and remember the derivative of e to the x is just e to the x, plus e to the x times the derivative of x squared is 2x, and the derivative of 3 is 0, so 2x. So this will give us x squared times e of x, so e of x, x squared, minus 3 e of x, plus e of x 2x. Now let's factor that. First let's take out an e of x, and that will give us x squared minus 3 plus 2x. And let's put those in the correct order, in descending order. That's x squared plus 2x minus 3. Now we can keep factoring here. The two numbers that multiply to be negative 3 and add to be positive 2 are positive 3 and negative 1. Okay, now if I'm looking for where this is equal to 0, then e of x would have to be equal to 0, or x plus 3 would have to be equal to 0, or x minus 1 would have to be equal to 0. Now think back to the graph of e of x. E of x is never 0. Okay, so there's no solution to that. Here we could subtract 3 from both sides and we'll have negative 3. Here we can add 1 to both sides and we'll have positive 1. Okay, so our critical values are here at negative 3, and at positive 1. Okay, so here you can see it's increasing and then it starts decreasing, and then it changes from decreasing to increasing here. Okay, now if we did the same kind of thing as we did before, we could pick points in each interval. Any point to the left of negative 3, less than negative 3, it's going to be positive slopes. Anything between negative 3 and 1 will have negative slopes, and anything greater than 1 will have positive slopes. Now let's look at one more example here. We see this graph, and if we want to know where it's increasing and decreasing, we need to find our first derivative. It's again a product rule. Well, let's do this first. Let's just simplify f of x. That'll make it easier to find the derivative. X cubed, or x to the 1/3 times x is x to the 4/3, and x to the 1/3 times negative 4 is negative 4x to the 1/3. Now that'll make it easier to find the derivative, because then it'll just be the power rule. 4/3 x, and 4/3 minus 1 is 1/3. Minus, bring your 1/3 out, 4 times 1/3 is 4/3, x to the negative 2/3. So we want to know where this is equal to 0, or possibly undefined. Because this one could possibly be undefined. And what we're going to do is, if we want to know where this is equal to 0, we're going to actually factor out 4/3 x to the negative 2/3. Now the reason I want to do that is if I multiply x to the negative 2/3 times x, that will give me x to the positive 1/3. Of course, 4/3 x to the negative 2/3 times 1 is 4/3 x to the negative 2/3. Now this cannot be 0, but remember that this is actually 4 over 3x to the 2/3. So it is undefined at 0. And then where x minus 1 is equal to 0, if you add 1 to both sides, is at 1. So your critical values are here at 0 and at 1. Now notice at 0, you can tell here, it does not change. This function is decreasing. These slopes are negative all the way through 0. Okay? Now it's not differentiable at 0. Okay? Here, it changes from decreasing to increasing. So it decreases for all the x's less than 1 and increases for all the x's greater than 1. And again, here's another little picture. You can, if you choose any value less than 0, your f prime is going to be negative. Between 0 and 1, your f prime is negative, so it doesn't change there. But greater than 1, your f primes are positive.